It is a world of crushing pressure and eternal darkness. Here, deep beneath the warm, sunlit waters of the Red Sea, lies a landscape that really, well, defies imagination. For centuries we believed the seafloor was a vast, uniform desert of mud and sand. But, modern exploration has revealed something far more extraordinary. Imagine for a moment descending in a submersible, your lights cutting through the inky blackness. The instruments show you are hundreds of meters below the surface, yet suddenly a shoreline appears. It's a sight so unexpected, so utterly alien, that early explorers could scarcely believe their eyes. They had found a lake, complete with its own distinct surface and waves, resting silently on the ocean floor. This was not a mirage or a trick of the light. It was a genuine body of water, separate from the ocean that surrounded it. The discovery sent ripples of excitement through the scientific community. How could a lake exist within an ocean? It seemed to break the fundamental laws of nature that, we thought we understood. The submersible's pilots reported that when they tried to land on its surface, their craft simply bounced off as if hitting a liquid trampoline. The mystery deepened with every new observation. This was a place unlike any other on Earth, a hidden realm that held secrets about our planet's past and perhaps the very nature of life itself. The vehicles that first stumbled upon these features were not looking for lakes. They were mapping the seafloor, charting the unseen mountains and canyons that shape our world. But the sonar readings came back with bizarre anomalies, flat, highly reflective patches that made no geological sense. It was only by sending down remotely operated vehicles, our robotic eyes in the deep, that the truth was revealed. There, nestled in a basin on the seabed, was a pool of liquid that behaved in a completely different way to the water around it. The boundary was so clear, so defined, that it looked as if someone had poured a different substance into the ocean, one that refused to mix. The feeling of seeing it for the first time must have been one of pure wonder. It is a reminder that even in the 21st century, our own planet still holds profound surprises. These underwater lakes are not just geological curiosities, they are portals to another time. They offer us a glimpse into the extreme conditions that may have existed on a younger, more volatile Earth. The quest to understand them was more than just solving a puzzle. It was a journey to uncover a lost world, one that had been hidden from sight for millions of years, waiting patiently in the silent, dark abyss for us to find it. So what exactly are these mysterious underwater lakes? They are known to scientists as brine pools. The word brine simply means water that is incredibly salty. The water in these pools is not just a little saltier than normal seawater, it is many times saltier, sometimes up to 8 or even 10 times as dense. This extreme saltiness is the key to their strange existence. The brine is so heavy, so much denser than the ocean water above it, that it sinks to the lowest points on the seafloor. There, it gathers in depressions and craters, forming a distinct separate body of liquid that acts just like a lake on land. It has its own surface, its own shoreline, and even its own unique chemistry. The surface of a brine pool is a truly mesmerizing sight. It shimmers and ripples, catching the light from a submersible like a sheet of polished silver. When disturbed, small waves spread across its surface, just as they would on a pond. But this is not an ordinary surface between water and air. It is a boundary between two different kinds of water. The normal, less salty seawater above, and the super-dense, toxic brine below. This boundary, called a halocline, is incredibly sharp. The transition from one world to the next happens in just a few centimeters. Above it, life is sparse but familiar. Below it lies a realm that is lethal to almost every creature in the ocean. The illusion of a lake is made complete by the surrounding landscape. The brine, being so corrosive and devoid of oxygen, preserves everything that falls into it. Unfortunate fish, crabs, or other sea creatures that wander too close and sink into the dense liquid are killed instantly. Their bodies do not decay as they normally would. Instead, they are perfectly pickled by the salt, lying on the bottom as if frozen in time. The edges of the pool are often littered with these preserved remains, creating a kind of dead zone that marks the lake's toxic boundary. It is a hauntingly beautiful, yet deadly shoreline. For a submersible, interacting with a brine pool is a strange experience. Because the brine is so much denser than seawater, the vehicle becomes incredibly buoyant when it touches the surface. It's like trying to push a beach ball underwater. The submersible will float on top of the brine pool, unable to sink into its depths without a huge amount of downward thrust. This is why early explorers reported bouncing off the surface. They were, in effect, floating on a hidden sea within a sea, a secret lake whose waters obeyed their own set of rules, completely separate from the vast ocean all around them. The reason these brine pools remain so perfectly separate from the surrounding ocean comes down to a simple principle: density. Think of what happens when you pour oil into a glass of water. The oil is less dense, so it floats on top, forming a distinct layer. The brine pools work in the opposite way. The brine is much denser than the sea water above it, so it sinks and stays at the bottom. The difference in density is so great that the two liquids have almost no desire to mix. Gravity holds the heavy brine firmly in its basin, while the lighter seawater floats gently on top. This simple, powerful force is what creates and maintains the sharp, lake-like surface. Imagine trying to mix honey and water. If you pour honey into water carefully, it will sink to the bottom and sit there as a thick, separate layer. You would have to stir it very vigorously to get it to dissolve. Deep in the ocean, there are no powerful storms or currents to stir things up. The water is incredibly calm and still. This tranquility allows the brine and the seawater to exist side by side for thousands of years without mixing. The boundary between them, the halocline, is a place of perfect stillness, a fragile wall of density that separates two profoundly different worlds. It is a testament to the power of physics in shaping the natural world. This principle of density also explains why the brine is so deadly. The extreme saltiness makes it impossible for the cells of most marine animals to function. Water is drawn out of their bodies in a process called osmosis, causing them to dehydrate and die almost instantly. Furthermore, the brine contains no oxygen. Because it doesn't mix with the oxygen-rich water above, any oxygen that was once in the brine was used up long ago by bacteria. It is an anoxic environment, meaning without oxygen. Any fish or crab that swims into the pool effectively suffocates and is poisoned by the salt at the same time. So, while it looks like a calm lake, a brine pool is one of the most extreme environments on the planet. Its separation is maintained by the fundamental laws of physics. The immense weight of the salt-saturated water pins it to the seafloor, creating a barrier that is almost impossible to cross. This barrier not only keeps the seawater out, but also traps other chemicals within the brine, such as toxic hydrogen sulfide and methane. This unique chemistry, locked away from the rest of the ocean, is what makes these pools not just a geological marvel, but also a fascinating laboratory for studying the limits of life. The story of how these brine pools formed begins an astonishingly long time ago, millions of years in our planet's past. During a period known as the Miocene epoch, about 6 million years ago, the world's geography was very different. The tectonic plates were shifting, and the connections between oceans and seas were constantly changing. At that time, the body of water that would become the Mediterranean Sea, as well as the Red Sea, became periodically cut off from the vast Atlantic Ocean. The Strait of Gibraltar, the narrow channel that connects them today, was closed by the movement of the African and Eurasian plates. This event turned these seas into giant, isolated basins. Trapped under a relentlessly hot sun, the water in these isolated seas began to evaporate at a tremendous rate. As the water disappeared into the atmosphere, the salt it contained was left behind. Over thousands of years, the seas became saltier and saltier, until eventually they dried up almost completely. What remained was an immense, barren salt flat. much like the salt deserts we see in places like Utah or Bolivia today, but on a vastly larger scale. Layer upon layer of salt crystals were deposited on the ancient seabed, in some places forming beds of pure salt that were several kilometers thick. This was a truly alien landscape, a desert of salt where an ocean once was. This colossal salt deposit did not remain exposed for long. Eventually, the geological forces shifted again. The land bridge at Gibraltar broke, and the Atlantic Ocean came rushing back in, refilling the Mediterranean basin in what must have been the greatest waterfall in Earth's history. Over millions of years, rivers flowing into the refilled seas carried mud and sand, which settled on the bottom. These layers of sediment slowly buried the ancient salt beds, trapping them deep beneath the new seafloor. The salt was hidden, locked away under hundreds of meters of rock and mud, a forgotten relic of a drier, saltier time. This same process occurred in other parts of the world, including the Gulf of Mexico and, of course, the Red Sea. In each of these locations, ancient seas evaporated, leaving behind massive underground salt deposits known as evaporates. These buried salt layers are the essential ingredient for creating a brine pool. They are a direct link to a different geological era, a time when our planet's climate and geography were undergoing dramatic changes. The salt that now fills the deep-sea lakes of the Red Sea is, in fact, ancient salt, preserved for millions of years and now bubbling back to the surface in a spectacular fashion. The ancient salt, buried deep beneath the seafloor, does not lie dormant forever. Salt has a very peculiar property. Under immense pressure, it can flow like a very thick liquid, almost like glacier ice. This process is called salt tectonics. The layers of sediment that settled on top of the salt are much denser than the salt itself. Over millions of years, the immense weight of this overlying rock and mud squeezes the buried salt layer. Just as you can squeeze toothpaste from a tube, this pressure forces the less dense salt to move upwards, pushing its way through cracks and faults in the sediment layers above. This upward movement of salt creates domes and pillars that warp the seafloor from below. Sometimes, this mobile salt gets close enough to the surface of the seabed that it comes into contact with the ocean water. When seawater, which is itself salty, seeps down through the sediment and reaches one of these massive pure salt deposits, it begins to dissolve the ancient salt. The water quickly becomes saturated, unable to hold any more salt. This creates the super-concentrated, incredibly dense brine. Because this brine is now much heavier than the surrounding seawater, it seeps back out onto the seafloor, flowing downhill and collecting in the nearest basin or crater. Another process, known as double diffusive convection, helps to maintain the sharp boundary of the pool. At the surface of the brine, heat and salt are trying to escape into the colder, less salty seawater above. But heat moves much faster than salt. This creates a fascinating effect where the boundary organizes itself into a series of thin, horizontal layers. Each layer is slightly warmer and saltier than the one above it. This staircase-like structure acts as a very effective insulator, slowing down the mixing process and helping the brine pool to survive for thousands of years. It is a delicate, self-organizing system that preserves the pool's unique identity. Together, salt tectonics and double diffusive convection create and sustain these remarkable underwater lakes. The slow, inexorable movement of ancient salt from deep within the Earth's crust provides a continuous supply of brine. This brine then emerges onto the seafloor, creating pools of liquid so dense and so alien that they resist mixing with the ocean around them. The sharp, shimmering surface of the brine pool is therefore not just a boundary, it is the visible result of immense geological forces and subtle physical processes working together over millennia, a dynamic interface between our planet's deep past and its present. For most forms of life, the brine is a death trap. Its high salt content and complete lack of oxygen make it one of the most inhospitable environments on Earth. Any fish, crab, or starfish that strays into the pool is killed instantly. And yet, life finds a way, not in the brine itself, but right at its edge. in the narrow zone where the toxic brine meets the normal seawater. Here, a unique community of organisms has evolved to not only survive, but thrive. These creatures are called Extremophiles, meaning lovers of extremes. They are mostly microbes, bacteria and archaea, that have adapted to conditions we once thought were impossible for life. These microbes perform a remarkable kind of chemistry. They feed on the chemicals that are abundant in the brine, such as methane and hydrogen sulfide, which are poisonous to most other living things. Through a process called chemosynthesis, they use the chemical energy from these compounds to create food, in much the same way that plants use sunlight for photosynthesis. This forms the very base of a unique food web. Mussels, clams, and tube worms cluster in dense beds right on the shoreline of the brine pool. They have formed a symbiotic relationship with these chemosynthetic bacteria, which live inside their tissues and provide them with all the nourishment they need. This ecosystem is completely independent of the sun. In the sunlit world, all life ultimately depends on the energy captured by plants. But here, in the eternal darkness of the deep sea, life is powered by chemical energy seeping from the earth itself. It is a truly alien food chain. The animals that live here have developed special adaptations to cope with the toxic environment. The mussels, for example, can tolerate incredibly high levels of sulfide, a chemical that would kill most other animals. They live in a precarious balance, drawing nourishment from the deadly pool while being careful not to fall into it. Studying these life forms is incredibly important. They show us the incredible tenacity and adaptability of life. They push the known boundaries of where life can exist, forcing us to rethink what ingredients are truly necessary for survival. These discoveries suggest that life might be able to exist in all sorts of strange and extreme places, not just here on Earth, but potentially elsewhere in the solar system. The brine pools are natural laboratories for astrobiologists, scientists who search for life beyond our planet. The microbes thriving at the edge of these toxic lakes could be models for the kind of life we might one day find on other worlds. The discovery of these underwater worlds in the Red Sea does more than just reveal another of our planet's wonders. It provides us with a window into the distant past, perhaps even to the very dawn of life on Earth. The conditions found in and around these brine pools, rich in chemicals like methane and ammonia, and devoid of oxygen, are thought to be very similar to the conditions on the early Earth, billions of years ago. It was in such a primordial soup, powered by chemical energy from volcanic vents or similar features, that the first living cells may have formed. The brine pools, therefore, might be modern-day analogues of the crucibles of creation. By studying the unique microbes that thrive in these extreme environments, we can learn about the fundamental strategies that life uses to survive. These organisms may be descendants of some of the most ancient forms of life on our planet. Their genetic makeup holds clues about how life adapted to a world without oxygen and how it learned to harness energy from inorganic chemicals. In a very real sense, exploring these deep-sea lakes is like time travel. It allows us to investigate the kind of biochemistry that may have kick-started the entire evolutionary journey, leading from simple microbes to the vast complexity of life we see today. This has profound implications for our search for life beyond Earth. When we look at other planets and moons in our solar system, we are finding worlds with conditions that are, in some ways, similar to these brine pools. For instance, Jupiter's moon Europa and Saturn's moon Enceladus are thought to have liquid water oceans hidden beneath their icy shells. These oceans are likely to be in contact with a rocky core, creating the potential for hydrothermal vents that could release chemical energy, the very same kind of energy that powers the ecosystems around the Red Sea brine pools. Life might not need sunlight at all. The brine pools teach us to broaden our imagination. They show us that life can flourish in places we once deemed utterly uninhabitable. The search for extraterrestrial life should not be limited to searching for Earth-like planets with gentle climates. It could be hiding in the dark, salty oceans of icy moons, or deep beneath the surface of Mars, anywhere there is liquid water and a source of chemical energy. The strange, isolated lakes on our own planet's seafloor are a powerful reminder. They tell us that the universe is full of possibilities, and that the spark of life may be kindled in the most unexpected and extreme of places.